Okay then, so talking about part C, we are told by the great god of statistics, who we cannot argue with, the actual population mean is 147, and we are asked to find the probability of a type 2 error at a 5% significance level, and then at a 1% significance level. First of all, we need to remember, what is a type 2 error? Let's get this focusing sorted out a minute. What is a type 2 error?
You accept H naught.
It's a probability, you accept H naught given H1 is true. Okay, that's what a type 2 error is. So that's the probability that we're after. Okay. If you want to write it down, everything in terms of H naught, it's a probability we accept H naught given H naught is false. That's just saying exactly the same thing. If you want to think of it that way, that's fine. Well, we're doing it first of all now for 5%. When do we accept H naught at the 5% level? Well, look back at your answer for part A. You accept H naught at the 5% level if the sample mean is greater than 148.355.
If it's lower than it, isn't it?
If it's lower than that, I think we reject H naught. You reject in the tail.
Oh, okay.
So we accept H naught if X bar is greater than that. So this probability line here becomes, it's a probability that X bar is greater than 1.8.355 given H1 is true. H1 is the alternative hypothesis. This is where the great god of statistics has some information that we need, so we're going to assume that the mean isn't what we said, the mean isn't 150, we're going to use that 147 that was told to us by the great god of statistics. So we're putting here given that mu is 147. That is just writing out the probability calculation that we need.
What's the top line say? It says probability type.
Find the probability for type 2 for 5%, and then we're going to do it for 1%. That was what part C was asking us to do. So, now then, we're just going to work this out. So, we want a greater than probability, so let's turn it around and do a 1 minus. There's my phi, and I'm going to put in that value. Take away the mu, the population mean, which we're told is actually 147. Over the standard deviation, well, we're dealing with X bar, that's still going to be the sigma squared over n, that's still 1. So that's how we work this probability out. To save you time, the value inside the bracket is 1.355. When you do your lookup, it's 0.9123. When you do your 1 minus, it's 0.0877, which is telling us that there's about a 9%, which is what that is roughly, a 9% chance of a type 2 error. So there's a 9% chance that we will accept H naught when we shouldn't.
Don't you have to do anything with the H1 is true part or not?
Hang on. The H0, the H1 being true bit is taken care of by changing the mu here to 147, which is the alternative that we are told. So that is part C done for 5%. We've only got about 3 minutes before the bell goes. So for part C, for 1%, you basically reproduce what you have done, but instead of using the 148 number from part A, you will change that to the 147.67 number from part B. And just for the sake of time, just going through that here, if I find my right sheet, here we go. For part B, when we change the significance level to 1%, we're now using this number. Apart from that, everything else is the same. I'll stick this on the KRP so you can have a full neat copy if you want to. And there's the calculation. Look at that answer. What's that percentage down there?
25%.
Yes, 25%.
Can you leave that there?
I'm not going to leave that there. I am going to move on because I just want to do this very last bit. So, what we have got here is this. When we had a significance level of 5%, there was a 9% chance we would come up with a type 2 error. When we had a significance level of 1%, there was a 25% chance of a type 2 error. And remember, these over here are the probability of type 1 errors, because the significance level is the probability of a type 1 error. So if you think type 1 errors are really important, you really don't want to have those, you want to make those small, this one goes up. If you say actually a type 2 error is the worst possible thing that can happen, I want to make that small, then the type 1 error goes up.
Why?
Because there's a balance there. If one error goes up, the other goes down. What is the way forward? And I'm going to say, Alex, what is the way forward, do you think, to reduce both types of errors probabilities?
Increase the sample size.
Increase the sample size. That's where today's lesson has got to end because of the clock.